Well, good afternoon, everyone. I'm Li Zhiluo from the Hong Kong Polytechnic University, and I'm a PhD candidate supervised by Professor Jeffrey Shen. And I will introduce a research paper named Smart Work Packaging for Constraints Management in Modular Integrated Construction. So from the title, you may have already noticed several keywords: smart work package and constraints management and modular integrated construction. So now you may have already know the research purpose that I have already developed a smart work package to facilitate the constraints management in modular integrated construction. So referring to the structure of a research paper, I will introduce the study from the following 5 parts. First, introduction, and followed by literature review, definition of the package and the functions, and finally discussions and conclusion. First, modular integrated construction, it is very popular method in the construction in Hong Kong. Why? Because Hong Kong has some very serious social issues, such as the shortage of housing. So we need a very innovative and efficient construction method. So what is modular integrated construction? It is a modern and innovative approach in the construction industry, and it uses the principles of industrialization and mechanization, automation, and robotics, standardization, modularization, and information-driven in the life cycle of the construction processes. It has various processes like the design, manufacturing, logistics, on-site assembly, maintenance, and deconstruction stages. So you know that in traditional construction, we only have the design, the construction, the deconstruction. So for the method of MIC, modular integrated construction, it has more processes. First, it has extra manufacturing process. It is production in the factory. And we need to transport the materials, the components, the modulars. They are finally, after the production in the factory, they will be transported to the construction site. So we have more logistics works. And then they are finally assembled in the construction site. So why we use the method of modular integrated construction? It is because it has some technical benefits in comparison with traditional construction. First, it has better quality performance, and sustainability. It means it can effectively reduce the construction waste, and it has materials usage. And in the schedule and the cost performance, after we use a lot of production of the modules, it will have the economic scale. So it could reduce the construction cost. And since the industrialization method can effectively reduce the repetitive work, so using the mechanization, the schedule could also be reduced, and better safety performance. So that's why the method of MIC is very popular in the densely populated cities like Hong Kong. So although we know that MIC is a good method, it has some problems in the integration process. First, it has various stakeholders like the designer, the factory, the transporter, and the assembly subcontractor. So we need to store, retrieve, and manage more information on their own isolated systems because they are individual stakeholders. So they have their own systems which are operated isolatedly. And the efficiency of the collaborative working and decision-making could be negatively affected by the fragmented information in the supply chain. So after a review of the literature and the studies of MIC, we noticed that there are several very big issues that need to be addressed. First, all the potential constraints prior to task execution cannot be timely satisfied, and the reliability of planning and control in the MIC process will be reduced. Finally, the schedule delay, cost overrun, and issues of quality and safety could not be avoided. In so many issues, we need to first mitigate the constraints in the MIC. So that's what I have already done. In the theory of constraints, I will first explain the issues of the collaborative and mitigation processes. First, the fragmented stages involve so many various stakeholders, which reduce the efficiency of decision making, and the independent activities involving so many tasks increase the complexity of the collaborative working, and the product-oriented MIC with discrete information components could not be well managed to generate the value-added information. So these issues are what I named constraints, which are the incomplete models, drawings, and the specifications, and the workforce materials, and the lack of work meets, as well as unidentified safety and hazard issues. So what's the difference between constraints and risk? Risk is something that may happen and they may not happen, but constraints, it is something that must or may happen in the supply chain. So a few literature reveals that we already have some methods to mitigate the constraint management. You may notice the keywords like IoT-enabled active sensing system, and mobile intelligence, and AR-based interface, as well as smart operators and cloud computing, and RFID-enabled positioning. So these studies provide the solid foundation for the potential of development of the smart work packages to mitigate the constraint management in MIC. The constraints in the supply chain of MIC have been divided into the physical categories and physical and information categories. In the physical categories, it has some issues like the typology, storage space. Why we mean the storage space? It is because Hong Kong is a very densely populated city, and the storage area is very limited. So in the construction site, we often have a lot of inventory, which may in fact negatively affect the layout management of the site. And safety and occupational health, temporary structures and site facilities, environmental conditions. And in the information category, the scope definition, it means the scope of the project. It may change across the supply chain. And the design information requirements, administrative information, and the quality inspection, transportation planning. However, there are a lot of gaps in existing studies and research in address the constraint management in MIC. First, the unresponsive implementation of constraints analysis, and the low transparency and poor foresight of the constraint status, and the non-optimal or inflexible constraint improvement planning. So regarding the limitations of the studies in constraint management, we developed the smart work packages. It has three characteristics. First, the adaptivity. Adaptivity means that the package could automatically deal with the issues and adapt to the environment. And the sociability means the package could communicate with the surrounding environment, while the automatically means the package in some environment, it does not need to be influenced by the surrounding environment, but automatically identify the uses and deal with the issues. So the MIC workflows, it is decomposed in accordance with the production breakdown structure of the building systems that are made smart by augmenting with the capacities of visualizing, tracking, sensing, processing, and left-working reasoning, so that they can be executed autonomously and adapt to the changes in their physical context and interact with the surroundings to enable more resilient processes. We have defined 3 functions of the smart packages, including the constraint modeling, constraint optimization, and constraint monitoring. For the constraint modeling, we first identified the constraints from the literature. You may have noticed the variables in the system dynamics diagram, like the inadequate storage space and the uncompleted temporary structures. Also, you may have noticed that these variables are not existing in the system individually, but they have a lot of interrelationships. So they are collected by the arrows, which reflect their relationships. Also, you may have noticed that they are concentrating on the physical and information constraints. For the constraint optimization, we have several steps for the optimization process. First, we calculate the proportion of the smart work package that each work phase should process, and then calculate the number of constraints that each workforce should process. For the third and fourth step, we create a randomized list of assignable workforces to the work packages based on the second step. Finally, we create a final list of the constraint to workforce assignment list. So after we have modeled and optimized the constraints, we need to monitor the constraints dynamically from the supply chain. First, we need to track the components of the MIC method. We use RFID and beam to track the status of the components, and then using the visualization function of the beam, we can see that there are several colors of the components. Like the yellow part, it means the component has already arrived from the construction site. And then the green color, it means the component is delivering from the factory to the construction site in Hong Kong. And for the pink color, it means the erection of the components has already been completed. So from that, we can know the dynamic process of the status of the components. Finally, based on the historical information, we need to predict and planning the further resource management in the supply chain of the MIC method. So, although we have so many expectations of constraint management in MIC, it still has some barriers and difficulties in the implementation process. First, it has some technical difficulties about the integral approach in constraint identification and their interrelationships mapping, and the efficient algorithms for dynamic replanning in constraint optimization, and the robustness hardware and software for the constraint monitoring. And there are also challenges about the technology acceptance, organizational changes, and cost issues. This is because the organizations or stakeholders in the supply chain, they already have their own systems. So they may be reluctant to the adoption of new systems, of new smart work packages. So they need to consider the technology and cost issues. Despite that, we still believe that smart packages could help facilitate the constraint management in MYC. That's all. Thank you.